In partnership with NASA, the Lockheed Martin Skunk Works team is solving one of the most persistent challenges of supersonic flight. X-59 QueSST is called Quiet Supersonic Technology will be used to collect community response data on the acceptability of a quiet sonic boom generated by the unique design of the aircraft. The data will help NASA provide regulators with the information needed to establish an acceptable commercial supersonic noise standard to lift the ban on commercial supersonic travel over land. This breakthrough would open the door to an entirely new global market for aircraft manufacturers, enabling passengers to travel anywhere in the world in half the time it takes today. The X-59 QueSST is an experimental aircraft that is being developed by Lockheed Martin for the American Space Agency NASA. Lockheed Martin was awarded the contract to develop a quiet supersonic plane in 2016. Since then the project has made significant development. The current plan is to transport the X-59 to Lockheed Martin's Texas plant, which is famed for housing the F-35 Joint Strike Fighter production line, for structural testing before returning it to Palmdale for the initial round of flight testing. As Eurasian Times previously reported, the disruptive noise and trembling produced by planes flying faster than the speed of sound are still major roadblocks to commercial supersonic aircraft. Although the sonic boom is only experienced briefly, it is really produced indefinitely as long as the aircraft is flying at supersonic speeds. Depending on when the supersonic plane passes through the region, various people will hear the thunderous impact at different times and at different points along the flight path. As a result, the United States and a number of other countries have put a ban on such flights in their airspace. The X-59 and the QueSST program's objective is to examine the technology that could greatly decrease the sound and felt impact of sonic booms on planes traveling faster than the speed of sound, as the name implies. The X-59 is an innovative design that makes extensive use of components from other Lockheed Martin aircraft in order to keep the design as basic and low-cost as possible. Landing gear from an Air Force F-16 fighter, a cockpit canopy from a NASA T-38 trainer, a propulsion system part from a U-2 spy plane, and a control stick from an F-117 stealth fighter is among the repurposed parts to be used on NASA's newest airplane. The X-59 structure, according to Lockheed Martin, would considerably reduce the decibel level of a sonic boom reaching the ground. The plane will take to the skies as part of a mission to gather data on silent supersonic flight and evaluate public reaction to supersonic thumps. The success of this concept could pave the way for commercial supersonic flights, which would substantially reduce the amount of time it takes to travel long distances. The firm's Demonstrator model is a single-engine plane with a length of 28.7 meters and a wingspan of 9 meters. The plane has an extended nose that reduces noise levels. The X-59 is driven by F414 GE100 turbofan engines that were specifically designed to be used on the plane. One of the more remarkable aspects of the design is the pilot's total absence of forward sight. Rather, the X-59's pilot will employ a remote vision system known as the External Vision System is called XVS to see through feeds from an array of forward-facing high-resolution cameras. This design enables the aircraft's complete front end to be more tuned for sonic boom mitigating supersonic flying. Additionally, the airplane was lifted away from the jig support system in late October of this year. This technology, which works similarly to scaffolding, ensures that all of the aircraft's hardware is correctly installed during the production process. According to NASA's official timeline, the X-59 will make its first flight by next year. Initial flight testing is projected to last 9 months and stretch into 2023. The initial flight testing will demonstrate things like the basic airworthiness of the aircraft,